Okay, hello. Welcome to a short video about how to answer differentiation optimization problems. In these types of problems, we're always going to be given some constraints. One of the constraints is here, I've underlined it in red. The volume of this tank is 500 meters cubed. And we're always going to get some form of algebra. So here we have an open water tank, so an open cuboid, and we've been given the dimensions x, x and h. And overall we need to find something to do with the surface area. Inevitably, what we're going to need to do with these types of questions is use a constraint, like we have here, to show some algebra. Now the reason they generally give you the algebra to show that it's true is so that if you're unable to generate it yourself, you can still do the rest of the question. But we can do this. I need to find the volume of a cuboid to start with and make that equal to 500. So x squared h equals 500. Now if I look at A that they've given me, I don't want any h's in it. So I'm going to make this equal 500 over x squared. So I'm going to rearrange for h equals. And the reason I know it's h equals is because there's no h in this equation here. Now, the surface area of a cuboid, an open-topped cuboid, I'd have x squared plus 4xh. I don't want any h's, so I'm going to make that x squared plus 4x 500 over x squared. And the reason I can do that is I know that h is equal to 500 over x squared. And if I multiply that out, I'll get x plus x squared plus 2000x over x squared, which is x squared plus 2000 over x as required. So now if I want to find the stationary point, that's where dy dx equals 0. So I need to find dy dx. Now before I actually start trying to find dy dx, I need to have the whole thing in index form. Now if you remember, 1 over x equals x to the power of minus 1, so 2000 over x equals 2000 x to the minus 1. If you're not unsure why, I could split that into 2000 times 1 over x. So I want to differentiate, so I'm going to have dA dx, because it's a equals 2x minus 2000 x to the minus 2. If you remember, you multiply the power by the coefficient. So I've got 1x squared, so I'm doing 2 times 1 for 2x, and minus 1 from the power. It's minus 2000, because I've got 2000 times by minus 1. Then I need to make 2x minus 2000 x to the minus 2 equals 0 to find a stationary point. Now 1 over x squared is x to the minus 2, so 2000 x to the minus 2 is 2000 over x squared. So I'm going to make it, say, minus 2000 over x squared, because it just makes it, I think, slightly easier. You hopefully can see from here I want to multiply by x squared, so I'm going to get 2x to the power 3 minus 2000 equals 0, so 2x to the 3 equals 2000, x to the 3 equals 1000, so x equals 10. Okay, so we're on to the final part of the question, in some ways the easiest part. We need to find the minimum value of a and then justify that it is a minimum. Now if you remember a minute ago we found that a was equal to x squared plus 2000 over x. And then in part B we found for this to be true, for it to be a minimum, that x was 10. So all I'm going to do is substitute x equals 10 into a. The reason I can do that is because we found in part B that x had to be 10 for it to be a minimum, or a stationary point at least. So a is 10 squared plus 2000 over 10, so it's 100 plus 200, so the minimum value for the area is 300. There's a few different ways we could show it's a minimum. One thing you could do is draw a picture of the graph, or I could find the differential for, say, x is 9 and x is 11. So we had dA dx was 2x minus 2000 over x squared. So when x is 9, dA dx is 18 minus 2000 over 9 squared. When x is 11, dA dx is 22 minus 2000 over 11 squared. This answer is negative, so at negative 542 over 81, and this answer is positive, it's 662 over 121. Now what that shows me when I'm going along the graph, the gradient is going from negative when x is 9 to 0 when x is 10 to positive when x is 11. So the only way that can be possible is if it is a minimum. I hope that's helped. Thanks very much.